So now that we've done the proper analysis on the intermolecular forces, we can also have a good look at how chromatography works. And so your syllabus just wants you to know, you don't need to know the other uses like the high pressure gas or liquid chromatography. So they're just going in the tools, it says thin layer or paper chromatography. So you just need to know the stationary phase for those are polar. So cellulose is full of glucose molecules with OH groups, and thin layer chromatography uses either a silicon or aluminium oxide layer that has polar groups on it as well. And so usually separates by polarity. So usually the solvent is a polar solvent, or you could use a non-polar solvent. So you just read the question carefully. We'll assume it's just water for these. And so the more polar it is, the more soluble it is in a polar solvent, the more it'll move up, which is not necessarily the case. So hopefully they'll tell you exactly what the solvent is, and so you can analyze how soluble it is, and the more soluble it is, the further it will move up. So you start here. Usually have a standard, so you know where the dot, if the dot lands here, what it is, and then you have your mixture that you're separating out, and this one has 2 dots. And so this is how far the solvent's gotten, but this is how far the different chemicals have moved up the solid phase. So this is actually a real example. You can see that concentration-wise, this seems to be more concentrated. The subject seems to have a slightly less concentration than the standards are. In each case, actually. So these, so this is the known, and this is the patient. So this one is weaker than that one, and probably stronger than that one. So, so whatever those values are, they're weaker or stronger, but you could use a machine to detect those things, use light or whatever. So it's qualitative and quantitative. Now, just doing a deep dive on those chemicals. I've left them in order. So if this was a polar solvent and these are the most soluble, which would have to assume, you can have a look and you can either guess that it was a polar solvent because you can see the solubilities here in water anyway. These solubilities are decreasing. And so why is cocaine higher than heroin and higher than methamphetamine? There's 2 conflicting things here. It's not just because they are different molecular weights. If that was the only difference, then the higher molecular weights wouldn't move up as high. But what's more effective is how polar it is. And there's a conflict between the two, so you wouldn't get that as a strict test question, but maybe a database question where you can see all the values and do a comparison. And so there's no polar groups on this, and so it's completely non-polar, so it's not moving up, even though it is half the molecular weight. Now, these 2 guys are sort of similar-ish molecular weights, but the polarity groups are equal. So they've got similar polar groups there that are attracting it to the liquid as it goes up. The only difference is this guy has a huge amount of non-polar weight to it. So that's the weight's going to slow it down, but also the fact that the weight is non-polar. If this was another polar group there, it may actually balance out, and who knows whether it's going to be the same, slightly higher or slightly less in that case. So maybe just more of a database question, which the exams seem to be moving towards. So that's just an in-depth analysis telling you why the solubilities are in that order. Now, what questions you normally get are determining RF factors. So so you don't necessarily need to do a standard because we know what the values are once we know what the type of solvent and stationary phase, etc., all are. So the distance that the dot moves, so where does it start? So the middle of that dot to the middle of that dot, and then the middle of that dot to the solvent front, really. So it's usually a fraction, so it's always the smaller one divided by the larger one. So the distance that the thing moves divided by the distance of the solvent. And so here's an example question. Scales are out here, so I can't get the ruler out. So the banned substance has an RF of 0.25. So the banned substance will be a quarter of this. It should be around here. And so that one didn't show up. These two things, I don't know what they are. But this one showed up and it's not there. So formula substitute units, so the answer is going to be slightly better. So you write the formula out. RF is sample divided by whole. We know the RF. Reorganize it. So the sample should be 2.5 of the RF. So it should be quarter of the way up. And it's not there. The other option is the proper answer. Or another way to write the answer, we actually do get the numbers and get the ruler out and do the measurements. And so that's example questions of what you could get tested on for chromatography.